Morning, ma'am. So my name is Ansh Jain, and I'm a student of BTech CSC. And today my topic is the applications of context-free grammar and speech recognition. So let us first understand like what are CFGs, what is exactly context-free grammar. So the practical definition of a context-free grammar that it's a formal grammar that is used to generate all the possible patterns of string in a given formal language. So these are the four tuples that makes the grammar V, which is a set of all the terminal symbols and non-terminal symbols, and T, which is a set of all the terminal symbols, P, which is a set of production rules, S, which is the start symbol. So if we come to this diagram, we can see that these are all the production rules, and what does it exactly mean? So when this S derives AB means that now this B as a non-terminal, it can generate AB, it can generate this B again. This is the set of non-terminals. This V represent the set of non-terminals, that is SP and F. S is the start symbol, and the summation depicts the set of all the terminal symbols that and the terminal symbols are A, B, and C. So let us see how a CFG is helpful, especially for the speech recognition. So this is a very common, or we can say a simplistic example how the CFG works for this speech recognition part. So as we can see, the sentence is being made up of a noun, phrase, and a verb phrase. Now, here we need to notice that it's an and operation, not or operation. So, which means that a sentence has to be built up with a noun and a verb. So, there's no choice between that. And coming on to the noun phrase, it can be made up of a noun or it can be made up of article and noun, which means article is followed by a noun. And the verb, it is made up of verb and a noun. So we can see the example of name. We can see the example for these sentences. So name we can use either he or she or John or Alice and so on. Article we can use a or in or the noun ball or bat basically or any noun we know. Verb eat, run or hit or read. So now we can see using this name, article, noun, and verb, we can build a sentence and here's the example of this sentence that is John eat a book. Now this doesn't make any sense if we see logically. The sentence is not grammatically correct. Hence, the grammar defines the syntax and not the semantics. So now we'll see how we can improve our context-free grammar. So we can use a probabilistic context-free grammar approach. So let's see what is that. So CFG can be made probabilistic by attaching a probability to each production rule. These probabilities are used in computing the overall likelihood of a recognition hypothesis sequence of words matching the input string the input speech. So this is the another view of this. The non-terminals which can be seen as functions in programming languages, where each production rule defines the function body as a sequence of statements. Terminals in the rule, however, likely ordinary assignment statements. A non-terminal within the rule is a call to a function, and thus the entire CFG is like a program made up of many functions. And obviously, a program execution can take up many paths. Each program execution produce a complete sentence. So the CFG can produce any number of sentences, which might not make any sense, might not be sensical, but they are syntax. They are correct if we are seeing in context of the syntax. Now we can see even a better approach by seeing CFG based decoding. So now let us consider the following example of CFG. So S is like an overloaded function which will eventually also create the entire program. So the call tree on the right side shows all the possible execution paths. So this is the path tree that is showing all the execution paths. So CFG based decoding is equivalent to finding out which rules were used in what sequence to produce the spoken sequence. Thus, this is the core algorithm that we are using when we talk about the application to use CFG in speech recognition programming. So, a general algorithm is to determine this is too complex to describe here. So, instead, we can try to approximate CFG by FSG. FSG is nothing but the finite state grammar. So, why do we need this FSGs? So, if we come to this parse tree, we can see S produces this S as a non-terminal produces ASB on the left side and a C on the right side. Now, C won't produce anything, but S can produce another production that is the ASB or C. So hence S can infinitely produce A, S, B and C till infinite. So there's no approximation, there's no end to it. So that's why we need that's why we need to approximate CFG by FSG. So let us see how do we approximate a CFG using an FSG. So the main advantage of the FSG back in the familiar is efficient coding territory. That's what we have seen. We need to approximate the CFG using FSG, as CFG can go infinitely deep and it can go infinitely long. So we need to approximate it. So let us come upon the disadvantage of the FSG. So it depends on the approximation method. So in some cases, the FSG will also allow some illegal sentences to become legal. And however, FSG will also disallow some legal sentences also. But this is still efficient than the CFGs as there's approximation to it. So let us consider some practical applications that can be made work very nicely. So many applications need only FSG to begin with. The errors committed by the approximate FSG can be made extremely rare. So let us understand FSG much better using this production rule. So consider a rule which says that X derives A, B, C, D, where A and C are terminal symbols and B and D are non-terminal symbols. So we can create the following FSG for the rule. So X being the starting symbol produces A, and A, since it is a terminal symbol, it cannot produce anything on its own. So it goes on to B, which can produce which produces C, and again C cannot produce anything, being a terminal symbol. So it goes on to D, which produces X, which is the end state. Now, it should be clear that when the above construction is applied to all the rules of the CFG, we end up with an FSG. So now let me explain you the framework of FSG. Although the framework is not that complex enough to enclose all the human languages, but in an is an approximation good enough for many purposes. For a natural language, a decent CFG can also derive more sentences in the language. Put differently, with high probability, a sentence can be parsed by a parser based on the CFG. The main issue with the CFG is to get fun, generally speaking. Learning context-free grammar from simple text is a difficult task. Also, at the same time, in a context-free grammar, which derives exactly from string, it is reduced to simpler grammar generating the same string. This achieves a lossless data compression. Context-free grammars can also be used in many applications in automatic speech recognition system that uses a dynamic programming algorithm for recognition and passing spoken word string of a context-free grammar in the Chomsky normal form. So now let us summarize whatever I've explained in this video. So we can see that the language models are essential for recognition accuracy, and LMs can be introduced into the decoding framework using the standard speech equation. So the formula for the P, that is probability, it's a buildup of all the different probabilities W1, W2 and up to Wn, which naturally leads to the notion of n-gram grammars for language models. However, the n-gram grammars have to be trained when little or no training data are available. One can also fall back on structured grammar based on expert knowledge. So, structured grammars are of two common types, as we have seen: finite state grammar and context free grammar. Here, we started a conversation with the context free grammar, and we saw that how finite state grammar can also be really helpful for the application of speech recognition. So the CFGs obtain their power and appeal from their ability to function as building blocks. So FSGs can easily be converted into sentence HMM for decoding. CFGs are much harder to decode exactly. However, CFGs can be approximated by FSGs by making some assumptions. So with this, I would like to end my presentation for today. Thanks for listening.